that I gave you last week. The very first one is the one that says, find the magnitudes of the x and y component to the nearest whole number. Vectors. You have it?
Yes, right here.
Good job. You don't need them all, just that one.
Oh, I don't know which one. Which one?
This one.
Oh, perfect.
Talking about vectors. Vectors. And I will tell you, this is in the book, but I don't like the problems in the book. They kind of expect you to know what this is and what's going on, and you probably don't. So, a vector looks like a ray that has magnitude or strength or whatever, and direction. This, if I talk about vector V, that means vector. It's almost like a ray on top of it, but it's just part of it. All right? This we talk about the vector. This means the magnitude of V, or how strong it is. A vector comes into play when you talk about wind speed. It affects something else. Or if you're in the water, the way the tide is going is a vector. Two people pulling against each other could be vectors. What we're going to do today is talk about different types of vectors and how to find their strength. Okay, if I tell you, as an example, that vector V is equal to 18. When I write it this way, that means the magnitude of vector V, how strong it is. All right? And if it has a direction of, let's say, 28 degrees, even though I told you we are through with trig, that doesn't mean you don't have to use it. Now, the good thing is, most of the time when you use it, not all the time, but most of the time, you'll use your calculator. All right? So, what I know is that I have the magnitude of vector V is 18, the direction is 28 degrees. Always from the x-axis. Isn't that how we measure angles? So if it's 28 degrees, that means this would be vector V, which is 18, and this is 28 degrees. Does that make sense to you? You are asked to find the x component and the y component, which means I'm going to draw a triangle. My triangle looks like this. This would be x, this would be y. Agreed?
Yep.
If I want to find y, is that opposite and hypotenuse? Is it?
Sure. Yeah.
Now you can't, I told you were through a trig, you can't just forget it all. What uses opposite and hypotenuse?
Sorry.
So is the sine of 28 degrees equal to y over 18. Yes? What mode should your calculator be in? Degrees. Isn't it just 18 sine of 28? So what would it, if I ask you to round it to the 10th, what would it be?
8.5.
8.5. How would I find the x component? Cosine? So the cosine of 28 is x over 18. What is x?
15.9.
That's the first part of vectors. Not bad, is it?
No.
Now, what if I have two vectors pulling against each other? For instance, I have vector u and I have vector v. Now, Sammy, can I pick on you?
Sure.
If I were to scoot this desk over, if he were to pull it that way and I were to pull it this way, which way would the desk go? Somewhere in the middle? It wouldn't go totally with me. It wouldn't go totally with Sandy. Do you agree?
I took the estimated physics approach, and I was like, well, it's like, the problem has a better stance. So.
Okay. Now, I was going to say the other side of that is, if he was standing up, if Sammy's stronger than me, it's going to go more his direction.
That's a big if right there, though. So.
Oh, okay, if I'm stronger than Sammy, it's going to go more my direction. So if I have, as an example, vector u and v, and if I told you this, what does that mean?
Not the magnitude.
Magnitude, or how strong it is. And I told you magnitude of v was 38, and the angle between them is, let's say 70 degrees. Okay? Now, what you need to know, first of all, is vector v is always on the horizon. What is horizon? Yes.
Oh. Got it.
Isn't the horizon always this way?
But yeah, I've not heard horizon in math before.
Oh. Okay, so this is v, this is u, and
Oh, we're
this,
making like non 30, 60, 90 triangles.
yeah,
Is that angle? Whoa.
that's what I have. What I know is my resultant, or where my object is going to go. This one's pulling 28 this way. This one's pulling 38 this way. It's going to go closer to V, isn't it? But it's actually going to go somewhere like that. Do you agree? Now, what I'm going to draw is what is that?
Parallelogram.
A parallelogram. If it's a parallelogram, what is this side right here?
U.
U. What I want to find is the resultant, and when I find the resultant, it will have a magnitude and a direction. All right? So my resultant, I'm going to call W. Do you see a triangle where W is the side? Do you? Okay. My triangle right here I have three sides, U, V, and W, but I need an angle in it. Well, I can't use tangent because I don't have a right triangle. In a parallelogram, I don't know what you remember about them, but consecutive angles are supplementary.
Oh, no.
Do you remember that?
This is
I
a
do not.
geometry.
Okay. Does it sound okay when I say it?
Sure.
This is
Yeah.
because we didn't pay attention to geometry.
So isn't
And
this 70? What would this be?
110. Oh.
Right?
I remember this. I just didn't like it.
Okay, all right. Do you see my triangle now? And I'm missing the length of side W. Right? Do you remember? W squared equals 28 squared plus 38 squared minus 2 times 28 times 38 times the cosine of 110.
Which thing was this? Because I remember this. I don't remember why.
Law of cosines.
Oh no! That was so. Oh goodness.
It wasn't that long ago.
It was. It was. A lot has happened since then. So it was a long time ago.
Oh.
It was a long.
Do you understand where I got all my numbers?
Yes. So we can still use cosine and stuff even though it's not a right triangle.
We can use law of cosines, yes. Law of cosines was for when it wasn't a right triangle. So what?
The angle is 110 degrees. The magnitude is
The angle is, we haven't found the angle yet. What is the magnitude?
54.4.
I did not get 54. I got 54.
Let's go.
Are you supposed to square? I didn't even
Yeah,
get
you
that.
have to square it the whole time.
Oh, square root it. Okay, that makes more sense. I just squared it.
Yeah, he got like 8 million something.
So close to the no, yeah. Oh yeah, 54.
Okay, so the magnitude of W is 54.4. Are you with me? The angle, or theta, that I want to find is this angle right here. You see that? Because it's the angle from the horizon. Okay? So, how would I find theta?
Since the parallelogram, can't we just have 70?
No, because remember we said it would be closer to V than it would U because it's stronger. Alright, is the sine of theta over 28 equal to the sine of 110 over 54.4? What is that we're using? Law of sines. Yes, no?
Is it what, 28.1?
Is that what you got?
I think so.
So, my magnitude was 54.4, theta was 28.9 degrees. That was a lot?
Yep. I'd rather keep down.
Huh?
We've done it all before now.
Yes, we have.
It was just
No.
pulling so much.
So let's do another one and let's see if we can do it without it feeling like it's so much. Okay? All right. U is 45. V is 32. And the angle is 85 degrees. I know I have a parallelogram. Yes?
Yeah.
Oh, I curved way too much. Is that what yours looks like?
Trying to figure out how fast we can do it. I think I figured it out on calculator.
Think?
Yeah.
What is this piece, this side right here? Is this you?
Yeah.
Thank you. So this is 45, and this is V, which is 32. Do you agree? Okay. What else do I know? I know this is 45, don't I? Okay. And what is this right here? 85. So what is this one? 95. Right? And this is W. Really, these are vectors. This is what is given, and this is how I come up with the picture. So do you all agree that W squared is 32 squared plus 45 squared minus 2 times 32 times 45 cosine of 95?
Wait, why do you have to do the minus 2 times?
It's law of cosines because it is not a right triangle. You agree?
I can't figure it out.
You think you figured out what?
How to do it quickly on the calculator.
Oh, good.
Yeah.
So what'd you get for W?
I have not got W.
Oh,
I got the angle though.
you got what?
For W, I got 57.4.
Anybody agree or disagree? That's what you got. Okay, was it simpler that time?
Yes. A whole lot simpler. I'm having, and it'll come eventually. Right now, I'm not taking a moment to figure out why we're using a lot of cosines. But I'll figure it out at some point.
Okay, so is it true? This is what I want to find. I always want to find the angle between W and V, because I want the one with the horizon. And V, remembers, on the horizon. So is the sine of theta, what's it over?
45.
Equals
The sine magnified over 57.4.
57.4. Right? What is theta?
1.46.
Was that better? Part of the first time we went through it, we had to remember all the stuff we knew about parallelograms. So what do you think? Are you good?
Do we have to write degrees with the magnitude?
Oh, no, it shouldn't have a degree. That's my fault.
No, that's just well.
Yeah. Okay. You have a worksheet?
Are we just doing, or is this, have we learned EE for all three of these?
Nope, just the first one. Do you have a worksheet?
Ooh, those worksheets.
You only need the one with the one on it. Yep.
Still do tomorrow?
Yeah, she didn't tell me it wasn't. Should have told you this option.